Welcome students, we come back again with a new video that's an give enough knowledge. So my name is Suman Upadhyay and you are watching Suman Sir classes. So let's start again. Today we discuss the following topics. The first one, that is the electric potential energy, because electrostatics chapter is going on. So electric potential energy first discuss. After that we move to the electric potential. Then we move to the point, that is the source charge is placed at the origin. Okay, we just want to find out the electric potential at any other points, so that the different cases arises due to these parts. Okay, so today we discuss mainly at first, that is the electric potential energy. After completing this episode, after completing this video, you can get enough knowledge. Okay, with the help of knowledge you can solve any type of numericals others problem without wasting your time. Let's start. So first of all, the energy. What is the energy? That you know, the different terms, different forms of energy is presents. The capacity to do a work. Okay, so this one specified with that. So one terms, that means the kinetic energy, and another one, that is the potential energy. So kinetic energy, that you know, what is kinetic energy? Due to the motion, the body gets some energy. This is called the kinetic energy. And when we change the positions of the body, it can get some energy. This is called the potential energy, that you know. And total energies remains conserved. That means some of the kinetic energy converted into the potential energy, or some of the potential energy can be converted into the kinetic energy. So that is conversions occur in this case, just like the others energy. Okay. So now we discuss the potential energy. What is the potential energy? Just consider, this is the electric field lines. Uniform electric field lines. This one all denoted with the E. Okay. So here a charge is placed. This is plus Q. Okay. So plus Q is charge is placed. This is called the source charge. And another charge it is placed over there. This is the it is also plus Q, but it is small one. It is called the test charge. So this source charge Q and this test charge, that is the small q. When the test charge is moving towards the source charge, that means it has some particular fixed distance. Just check it out. This one positive, both these. So when the test charge is moving towards the source charge, that is along these directions, this test charge is placed in the electric field. So obviously the main force acting on the charge, that is the electrostatic force, so that is equals to Q into E. So due to the charge, when both are positive, when two charges are positive, that means the force between them obviously repulsive in nature. So this force is repulsive. Okay, so repulsive nature the force is. Okay, now if I apply some force externally, to move the charge body towards the source charge, then due to the external force we just change the positions of the charge from this point to that points. By this force, it is the externally acting force, and by externally acting force we can change the positions. So when we apply external force, the what has to be done? Okay, let's see. We just discuss here. So consider this one is the part. Okay, consider two charge body. This one is source charge, this one is the test charge. So the distance between them is fixed. Okay, so just like that, the distance between them is fixed. Here it is. Now source charge is placed at these positions and test charge is placed at these positions. When the test charge, when we externally apply the force over there, just like that, just see that the charge body is moving in the forward directions, but externally forces acted. If the two bodies are positively charged, so repulsive force acting between them. When the repulsive force acting between them, it is not possible easy for us to move the charges, move the test charge in the forward directions. Understood? So that means the force between them, it is acted. This force is obviously repulsive in nature. If I want to move the test charge towards the source charge by using some external force, okay, so that is external force acting in the opposite directions of the repulsive force acting outward directions. but the external force acting inward directions. Okay, so that means when we want to move this charge, test charge, in the forward directions of the Q, so we apply a force in this case just like that. Okay, but the repulsion force continuously is trying to move in the backward directions. So this nature, that is the force to acting in the opposite directions, it is the occur in this case, and this body, this test charge is moving in the forward directions, so therefore potential energy is needed. What has to be done? So this work done can be specified as the potential energy. So let's see, we just want to find out, that means repulsive nature for can be, or repulsive force is equals to the external force. If external force, this one, this repulsive force that is occurred due to the both the charge is positive, and due to this force, an external force acted on this body. This force try to move the body in the forward direction. This external force is equal to the repulsive in nature. Now you tell me, repulsive force acting in which direction? In that directions. Okay, but external force acting in the which direction? In that directions. Okay, so external force, this one is the F external, so both are acting in the opposite, so negative sign generally occur in this case. So if I write the W, that is the total work done, consider this point is A and this point is B. Okay, so that means when the charge is moving from the B positions to the A positions, that means the body initially at the positions B and it is moving to the positions A. So therefore what has to be done? What is the work done? That is equals to force into displacement, that we know. So that means if F external dot displacement occur in this case, this displacement can be, if I say that the displacement is very small, so it is specified with the dr. So dw work has to be done when the charge, test charge, is moving a smaller distance, that is the dr. Clear? So when the charge is moving a smaller distance dr, so you just we say this one is point B and another point, this one is A. So this small distance is specified with the dr. This one. Okay. So this small distance, this is specified with the dr. So when the body, so the force is acting on this case, that is the main things that is occur, that is B to A, that is the Fx dot dr. But this work done is applied in which directions? Opposite to the repulsive force. That's why a negative sign arises in this case. If external dot dr. Okay, so due to this external, this is change the value, that is the negative sign occurred in this case. So we just write the W, total work done, that is equals to A to B if x dot dr. Now it is clear? Okay, so now we move to the next part. So W equals to minus A to B F external dot dr. This is the part. Now in the definitions of the potential energy, electrostatic potential energy, just which we want to know about that. That means from infinite distance, okay, that is considered the charge is placed at the infinite distance. So this one is Q. So from infinite distance, if the charge can move within a specific distance in the source charge region, that is source charge is placed, so surrounding of it there is a field also present. Okay, now this test charge Q, it is moving from infinite distance to the particular electric field, okay, at some fixed distance apart. So we just repeat once again, this source test charge Q plus Q, it is moving from infinite distance to a particular electric field of a charge, okay, that is plus Q. Due to this movement, what has to be done? Because this charge is moving from the infinite to the distance, here within this field the main force acting, that is the repulsive force. This repulsive force, against this repulsive force, the charge body is moving from infinite to the specific field. So that's why it is the force acting in this case. So potential energy we just written in the forms. Consider the potential energy. The charge body is moving from these positions to that position. That is the positions of the B. So at the positions of the B, potential energy, consider this one is UB. And initially the charge body is placed at the infinite distance. So that is equals to U infinite. At the positions of the U infinite, there is a no repulsive force is present. Because repulsive force is present within a surrounding region, that is within a surrounding field. Therefore, at the infinite positions, there is no force is present. Therefore, the U infinite, that is obviously equals to 0. So only present in this case, that is equals to UB. So due to this force, this is called the potential energy in this case. That is the charge. It is moving. That is the unit charge moving from infinite distance to the specific field. The work has to be done. Okay. This work done can be specified as the potential energy. There is the plus Q amount of charge. From these considerations, the concept of electric potential will arise. So what is the electric potential? Electric potential means this work done, that is the charge is moving from infinite distance to the specific distance. Okay, so what has to be done? So this work done per unit charge, if I moving a unit charge from this case, then it is called the electric potential. Okay, so electric potential, that is the, in this case the total work done is UB. Okay, so electric potential, it is denoted with V. That is obviously equals to total work done. Total work done if I consider W, so that is equals to W by Q, because Q amount of charge plus Q amount of charge moving from infinite distance to the within the field. So in this case the work done, that is the total work done per unit charge, that is equals to W by Q. This is denoted with the electric potential. Okay, so electric potential has some specific property. First one, it is a scalar quantity. Obviously, it is W work done. Work done is a scalar quantity, and charge of a body it is also. So that is V. That is the potential. It is a scalar quantity. It is a negative line integral of the electric field between the infinity and the given points. Now what is W? W is the potential energy. This one. Okay. So that is UB minus UV infinite. Okay, so that is the work done. So that is work done, W equals to minus integration of B to A F external dot dr by Q, this one. So the negative sign is arises in this case. Negative sign due to the repulsive force, because the external force acting along this direction, repulsive force acting in the opposite directions. So this negative sign arises in this case. So that's why it is a negative line integral of the electric field between the infinity and the given points. So this line integral taken over the line, that is equals to from B to A. Okay. So that means line integral of the electric field between the infinity and the given point. Infinity to a given point we just taken in this case. Okay. And the next one, that is the electric potential, is inversely proportional to the distance from the source charge. That is distance of the source charge, it is increases. Therefore, the electric potential decreases, because when it is just appeared very close to the Q, capital Q, that is the source charge, obviously it is electric potential is increases. That is distance increases, that means electric potential decreases in this case. Okay. Now the last one, that is the SI unit. SI unit of electric potential. What is the SI unit in this case? Now V equals to written in the form, that is equals to W by Q. Now what is W? That is the work done. Work done can be measured in the SI unit, that is 1 joule, and coulomb, the charge is coulomb, so joule per coulomb. So that is joule per coulomb. It is written in the form, that is the unit is volt. Okay. So this is the definitions of the volt. So we just discussed about the electric potential energy. From the electric potential energy, we just derived the electric potential, the different characteristics of the electric potential. Now we move to the next part. At the different positions of the source charge, we just want to find out the electric field or the electric potential in this case. Okay, let's see. Okay, so the next one, that is the electric potential at any point. Next case, this one. electric potential at any point when the source charge is placed at the origin. So let's take again, there is a plus Q charge. Plus Q charge is placed at the origin O. Okay. So we just want to find out the electric potential. Last part we discussed about that. What is the electric potential? That is from infinite a charge. Okay. From infinite to a specific field, if I move a charge, unit positive charge, okay, the work has to be done in this case. This work done is called the electric potential. So that means a charge is moving from infinite distance to a specific field, specific distance. Okay, during this process, a work has to be done. This work done is called the electric potential. Okay, so let's see what is the electric potential in this case. Now, when the charge, consider that from infinite the charge plus 1 charge, it is moving. Okay, this one is plus 1 charge. This plus 1 charge is moving from infinite distance to a specific field. Okay, up to the point P. At the point P, we want to find out the electric potential. So during this procedure, when the charge is moving from infinite to the specific field, during this procedure, we just consider the 2 points A and B. That is, the charge body is moving from infinite to a specific field P. Okay, during this process, we consider the charge can move from A to B within a small distance of dx. Okay, very small distance. That is, the charge body is moving from the A to B, just like the previous one. So that is, the source charge is placed over there, okay, and the test charge, this one, it is at the positions A. Okay, so at the positions A, it is moving from A positions to the B positions. So that is, here the force, this one is positive charge, this one is positive, and this one is the plus Q charge. Okay, so positive and plus Q. What is the force between them? Repulsive in nature. So against the repulsive force, we externally acting force. That means the charge body is moving in the forward directions. Which directions? From A to B. This one. From A to B positions. Clear? So this distance, that is the moving in this case, that is the value is dx. So we just want to find out the total work done in this case. That is dw. So what is the dw? dw equals to, that is in this case, the electric field. This one positive, this one is the positive. This one positive plus Q, and this one is plus 1 charge. Okay. So the main force acting on this case, that is the repulsive force, that is the electrostatic force. The field in this case, that is the electric field E. Okay. So within this electric field, a charge is moving through a distance of dx. Which charge? That is the unit positive charge. So that means dw equals to, here the force obviously experienced in this case, that is equals to E, and this E is multiplied with the part that is equals to dx. Okay, so dw, that is the work done, that is equals to E dot dx. Total work done, this is E dot dx. dw work done, so that means it is a scalar quantity. So it may be written in the form that is equals to E dx cos 180 degree. What is E dx? Because in the presence of electric field E, the charge body plus 1, we just repeat once again. In the presence of electric, throughout of electric field is present, that is equals to E. Okay? In the presence of electric field E, the charge plus 1 is moving from A to B, this distance. Okay? This distance, that means the distance dx. So what is the work done? Force into displacement. Here force is the E. Okay, this one. And displacement in this case, that is the dx. So E dot dx represent the total work done, that is the dw. So that means, so what is the value in this case? Dot product. So dot product, that means E dx cos 180 degree. Why it is 180 degree? Because the electric field acting in that directions. Okay, because repulsive in nature, so electric field acting in the outward directions. And the charge body is moving inward direction. So dx moving inward direction, electric field moving outward direction. So what is the angle between them? That is the 180 degree. So for these reasons, it is taken as a 180 degree. Now cos 180 degree value, that is equals to minus 1. So we just write in this case, that is equals to minus E dx. So it may be written in the form, that is dw equals to minus E dx. Okay. So what is the value of E? So what is the value of E? According to the, that is electric field equals to force by charge and not into Q by x square. Because we just want to find out the charge body is moving from A to B at the positions B to the origin. This distance is specified with the x. So that is equals to Q by x square. So now putting the value here. So dW equals to minus 1 by 4 pi epsilon naught Q by x square. This one into dx. Okay. So total work done we have to find out. So W, that is equals to integration of 0 to W dW minus Q by 4 pi epsilon naught. Now this charge body plus 1 charge, it is moving from which distance? It is infinite. That is infinite distance to the specific field. That is which field? That is from the point P. Okay. So distance of the point P at the positions point P. We want to find out the electric potential. That is infinite distance. The charge is moving at the point P. The point P, that is at a distance R. So we just write here integration limits from infinite. The charge body is moving up to which distance? That is the distance is R, smaller. Okay. So 1 by x square into dx. Clear? So now it may be that is equals to minus Q by 4 pi epsilon naught integration infinite to R. It is written in the form that is x to the power minus 2 into dx. So that is minus Q by 4 pi epsilon naught. When we integrate it, we get the value minus 2 plus 1 by minus 2 plus 1. This one, this part, that is infinite to R. Okay. So that is minus 2 plus 1, that means obviously minus 1. So that is minus Q by 4 pi epsilon naught x to the power minus 1 by minus 1 infinite to R. This minus 1 appear in this form, that is Q by 4 pi epsilon naught 1 by x power of infinite to R. It is the range. That is the total work done. So we just write in this case. So W equals to Q by 4 pi epsilon naught 1 by R minus 1 by infinite. And 1 by infinite, that is the value, that is equals to 0. 1 by infinite, it is equals to 0. So we just write this one, that is Q equals to 4 pi epsilon naught into 1 by R. So this is represent the work done. This work done is specified as the electric potential. So by this considerations we just say this one is the electric potential. So electric potential, what is the SI unit? In this case V. Okay. So today we discuss about the part that is electric potential at any point of the source charge of the place at the origin. Okay. Today we discuss the part, others part also, that is electric potential energy, electric potential. Okay. By one. So watch my video again. That is all this part, that is from electric potential and the capacitance. Okay, it is given one by one. Follow my playlist also. That is the within this playlist, that is electric potential and capacitance. We just added all this video one after another. Okay, so thank you everyone. Keep watching my video and subscribe my channel. So thank you.